always love it when I hit record and a train flies past, but we'll ignore it. I'm going to hazard a guess, folks, and I'm pretty confident I'm right, that you guys know what that is. I'm pretty sure that you could tell me that we've got a set of lungs there, kind of cross-sectioned. We've got a trachea leading up to the mouth and the nasal cavity, and the trachea is kind of branching off into the two bronchi and into the lungs, into the hemispheres of the lungs that way. I'm pretty sure. I even think you would be able to tell me, well, James, those bronchi, they branch off into bronchioles. I'm pretty confident also that you'd be able to tell me that the air that goes in and out ends up in these sort of tiny microscopic air sacs that are called alveoli, each one of them an alveolus. I reckon you know that, right? I also reckon you know that air moves in and out of those lungs constantly throughout one's life, unless we hold our breath, of course, swimming underwater or whatever that might be. I think you guys know that. I think that to you is common sense. My question to you is how? How does it happen? Now, if you know exactly and you know every single process goes on, you might find this tutorial quite easy. If, however, you think, well, actually, I'm not totally sure how that happens. How does that get in there? Why does the air sort of get sucked in that way and blown out in that way? What is going on in that? Excuse the sound effects. What is going on in that kind of environment? And the reason I sort of raise all of this is because these are not the only structures involved in breathing. We also have this one. Now, that one, first of all, I'm going to label for you. This here is a muscle. And that muscle there, and we'll look at other muscles in a second, that muscle there is called the diaphragm. And that diaphragm, as you see, it sits at the base underneath the ribs, and it's kind of like an archway, like marble arch somehow there, right? And it's sitting there, some kind of arc de triomphe, but where am I going with this? Below the lungs, and it's sitting almost like as the base, the floor of the thorax or the thoracic cavity. It's sitting there, right? And this, as I said before, what you're seeing now is that's it in its resting position. It's in resting position that way. Now, if I introduce some other muscles to you, and you'll see here we've also put the rib cage on top as well. These muscles that you're sort of seeing in aqua green, aqua blue here, the ones that you're looking at right there, these are referred to as your external intercostals. Okay, so those are your external intercostal muscles. Now, let me tell you, and by the way, just so you have it clear, folks, the diaphragm is still there. It's just underneath there, if you see what I mean. So I'll just sort of tuck it away for now and hide it under there for you. That's what I meant to do. Hang on, didn't do that right. I want to put it to there. So you'll see that disappear, but just know it's under there. Now, the point I want to make is as follows, that when we breathe out, okay, let me just put this in rest here. When we breathe out, both of these muscles relax. Okay, so when the external intercostal literally means in between the ribs, when these muscles relax and the diaphragm relaxes and goes into its dome shape, what happens there is that the ribs and the chest cavity sort of shrinks down and moves downwards, sort of, that kind of chest going inwards that you'll be accustomed to, right? That is what happens when we breathe out. Why does that work? It works because this entire area, which I'm going to get rid of that circle, that thoracic cavity, so the TC, it gets smaller and we breathe out. But when we breathe in, what happens is that this muscle and these muscles, they contract. So let's think about what happens in that situation. The diaphragm, which is sort of underneath here, it kind of levels out and becomes a bit more like this. Okay, I'm only drawing a pretty poor depiction of it, but it sort of levels out. That pushes the ribs outwards, and it also pushes them upwards a little bit. What's that doing? It's increasing the size of the thoracic cavity. Meanwhile, our external intercostal muscles, they pull upwards, and they lift the ribs up. So, of course, that increases the size of the thoracic cavity, and the air gets literally sucked in through the mouth or the nose. That is exactly what happens, and then we repeat that cycle. That is how the mechanics of breathing at rest are occurring. So I want to be clear here, folks. At rest, in resting conditions, the only muscles involved are the diaphragm and the external intercostal muscles. And to breathe out, all they do is relax. That's it. But of course, sometimes we start exercising. And you might have noticed when you're exercising that two things change about your breathing. First of all, and literally first of all, the depth of breathing changes, and later at higher intensities of exercise, the rate breathing changes. In other words, we breathe faster, or when we finish exercise, it starts to slow down again. So, first of all, we want to ask the question, well, how do we breathe deeper? What is your common sense telling you? How do we get more air in to our lungs? What would that muscle and that muscle have to do? And the answer to that is they contract stronger, harder, more forcefully. That is it. Now, we start exercising a little bit more hard. Maybe we're up in the tempo a little bit. And these muscles are now, the diaphragm and external intercostals, they're now at their maximum. What do we need? We need more muscles. Okay, we need more muscles. And which muscles do we need? Well, let me give you I'll only sort of sketch these on here. We have some muscles which come from the back of the head, down here, onto the down here, onto the sternum, all the way down here. And these are called your SCM. Now, awful word, sorry about this. They are called your sternocleido, and it's all one word, by the way, mastoid. And what these do, folks, is they pull upwards and further increase the size of the thoracic cavity. They pull up harder and further, and therefore the diaphragm and the intercostals get a bit of help. Brilliant! We've now got a more forceful contraction. Meanwhile, we've got some other muscles, actually insert quite similarly. They come down here onto the clavicle. These are called your scalene. One is your scalene, or your scalenes is the pair. Your scalenes do the same thing. Meanwhile, you've got some kind of big pectoral muscles here on the front of the chest, here and here. And what they do is they contract outwards like this. Further, these are your, I'm just going to use the term pectorals, really your pectoralis minor, but it doesn't matter. But these pectoral muscles, they'll pull outwards, lifting the ribs further up, increasing the size of the thoracic cavity. But notice, when we breathe out during non-maximal exercise, what's happening? Those muscles all relax. It's only when we get to really heavy exercise, let's now think about heavy exercise, that things start to become active with regard to breathing out. When we breathe out, folks, let's say we're really going for it. We're at the sort of like the peak of our hockey performance or a tennis, a long rallying test, in that kind of like real dragging the air in as fast as possible sort of situation. This is what happens, folks. We have got a whole series of abdominal muscles here. Your abdominals, now I'm drawing them very poorly, but your abdominal muscles here, what they do is they pull down during expiration, breathing out. They literally pull the ribs down, pull them down. Also, actually behind these intercostals, there's another layer of intercostals, and they are called your internal intercostals. And simply, they're exactly the same as the external, except that they sit behind the others. And the other thing, folks, they are literally topsy-turvy. So instead of being this way up, okay, with maybe like this, pulling upwards, they are this way up, okay? Sorry, so this is the external ones here, and these would be the internal ones. And what happens, of course, is they pull the ribs down. They pull the ribs down in this way. And as a result of that, our breathing out, listen to this word very specifically, becomes faster. So when we increase the rate of breathing, the only thing we do is recruit the rectus abdominis, the internal intercostals, and that causes the breathing out exhalation to be faster. Everything else is active because of, or the inhalation is active because of the contraction of the muscles we talked about. It's only at maximal exercise do our expiratory muscles kick in, and they increase the speed, the rate of breathing as a whole, because we breathe out faster. Do check other tutorials depending on the course you're doing, such as lung volumes and regulation of breathing. These are quite interesting topics to go alongside this. Obviously depends what you're studying, but that's something you want to be thinking about. Cheers.